Hey guys, I'm gonna do a little rock identification for you. I'm sorry I've been MIA. Anyway, we are going up north for the 4th of July. And for my 50th birthday is in November, and we will be going probably to Sudbury again. Because I love Sudbury. And anyway, that aside, I'm gonna show you, we're gonna not only classify this rock, but we are going to interpret as much as we can. Now, I'm going to pretend I don't know where this is from, okay? Now, petrology professors, petrology is a test where you actually identify rocks based off mineralogy, and you can do thin sections or you can do the standard tests, acid, scratch, Hanlon's, all that fun stuff that I do quite often. But that's basically petrology in a nutshell, okay? It's a little more in depth than that, but it's not just like looking at a rock and going, oh man, that's rocks for jocks, It's a lot easier to differentiate salt from any other rock than it is, gabbro from, or a dacite sometimes from a basalt, Or I can show you places in Wisconsin where you have a pink rhyolite right next to a dark rhyolite. So this is no rhyolite here, just using as an example. Okay, so let's get to this because I want to show you some stuff here. First, we're just going to look at the mineralogy and classify this rock. Now, this rock clearly has at least two distinct parts to it. Do I have to call it one thing? No, I can divide this out. I can say the dark part of the specimen or something like that is blah, blah, blah. The lighter part is blah, blah, blah. The pink part, you don't need to just settle on one rock type because obviously you have two here. So we'll start with the dark. Now, I will tell you both of these are igneous, okay? We're just gonna give that away. Now we look at the dark part. What do we see? Now you might be tempted to just blurt out, oh, this is a basalt. In this case, you'd actually be right. But how do we know that? Well, here you can see you've got good sized crystals. Some can be seen with the naked eye. Oh, and just so you know, this is 6 inches long, this pen, 15.2 centimeters, just so you know. But you can see there's some couple millimeters here that are good size. Now, the definition, the separation between aphanitic and phaneritic, the old volcanic versus plutonic way of naming things is, crystal size. This is really close to the border, but I'm going to call it aphanitic. I'm going to say it's, fine crystalline. It's obviously not microcrystalline, but it's fine crystalline enough. There's enough fine crystals here for me not to call it a gabbro. Okay, but how do I know this is a basalt? Well, you look at these dark minerals here, and I have looked at them. There's like no olivine and no pyroxene in here. It's all hornblende, it's all biotite, amphiboles, those kinds of things. So whatever this intruded in, or whatever, I don't know if it intruded, and we don't know who intruded who yet. We don't have a lot of leftover olivine and pyroxenes, which tells me this did not cool drastically really fast from a high temperature. It cooled fast from moderate temperatures. But how do I know it's a basalt? Well, basalts also have plagioclase in them and quartz. Now, you look really closely under Hanlon, you'll see some quartz. So this is not quartz. It's silica-like, but it's actually a plagioclase. It's a gray plage, okay? And it just fills the cracks, okay? But this, I picked this rock because you can see the plagioclase. This white is not quartz. It is plagioclase, okay? And what else do you see? You see a preferred orientation because of that. And if you look at the rock too, you'll kind of see that this is your dip, your foliations. Obviously, we can't get actual strike and dip off of this, but if it was in place, we could. And this would be your strike, and then you could measure your dips right off here. See, because you've got this preferred orientation, and it goes this way. Okay, strikes this way. All right, which is going to be different than this, which is going to which is going to tell us something. Okay. So we got that. We know it's a basalt. Now let's get to this pink part. Now we look at this and we look at the pink and we can tell that there's not a lot of striations in here. Some of this stuff is striated. That is, but then you look at stuff like this and it's not. Most of this rock isn't. What does that tell us? That tells us that this pink is dominantly K-spar, potassium feldspar, alkali feldspar. It's all the same thing, okay? Which one is it? I don't know. It could be sanidine, and actually, I think it might be. But anyway, it doesn't matter. There is some plagioclase, but it's a small percentage. You also see there is quartz, like this is quartz. This is quartz. Where is it? Oh yeah, this is quartz. Now this is a granitoid. This here is a granitoid. It's not a granite. Granite is specific ratios of quartz to plagioclase to K-spar, QAPF diagram, or foids if applicable. But since we have quartz, we know we don't have foids. We can't. The two can't form together. We flip it over, see what other information we can get, if any. You can see this doesn't really tell us much about the mineralogy. It's more broken here, jagged. Doesn't break on preferred planes like this does. So this is what, this is what we call cleavage. That's essentially what it is. Yes, you can get cleavage in igneous rocks. Anyway, so we notice we have a little bit of quartz, not too much, a little bit of plagioclase, and a lot of K-spar, a lot. So that's basically going to tell us that this is a cyanite. I mean, and the crystals this is definitely phaneritic. I mean, these crystals are, some of them are dang near a centimeter, okay? Most are about a third to a half, though. So, but that's definitely phaneritic. It's not really, excuse me, I wouldn't call it a pegmatite, okay? Sorry, I keep moving the camera. I'm about to cough hysterically, and I'm trying not to. And I'm sorry about the phone in my hand, but I have nothing to set it on. All right, this is very impromptu. Now that we know we have a cyanite and a basalt, who intruded who? What else can we tell about this? Can we determine that? Can we determine environmental setting? Can we determine temperature? Can we, of the magma that emplaced this? Can we find out how much water was in this? Now, knowing the ratios of minerals and knowing the minerals you have can drastically help you in interpretation. All right, but you got to look for other things. You look at this rock. There's some things I specifically have not talked about. You see this is a contact. Let's call that a contact, okay? It is an unconformity too, all right? You zoom in and you can tell, and you can see the coloration difference here and here. This has been baked. So our basalt has been baked. And this here is relic basalt on the other side. So this bloody thing was a dike or a sill, I don't know. That's about what, 2/3, so about 4 inches. 4 inches in width maximum. I don't know how much it is this way. So we turn it over here, we can see this is more weathered, so we can see the baked better. It's starting to decay and weather out better. Remember, mafic minerals like the weather first too. So, and you can see more white here. So this is actually a decent amount of plagioclase in it. Anyway, I digress. So is there any other lines of evidence that this, our cyanite, intruded our basalt? Yeah. See all these little black spots in here? You notice most of them are right around the basalt. And that holds true for this side as well. Look at them. They're almost all right by the basalt. You have a couple exceptions, okay? But the vast majority of them are here. Here. You have like none in the middle here. And there's some here. These are xenocrysts of the basalt in here. And you can kind of see one that almost broke off but didn't. So this was hot enough to give this some plastic deformation to it. And you look at it, does this have preferred orientation? It's hard to see on the screen, but it does. It goes this way, almost like columnar jointing. So this would have been injected either this way or this way. I don't know which way is up on this rock. As where our basalt has a preferred orientation of this way, of dip, with this as strike. So yeah, that tells us we have two different magma sources from two different distinct times. This is significantly later than this. It's not like this was a million years later or 20 years later or whatever. I mean, it was millions and millions of years later. And likely this is an old crack or small fault. Okay, and this was injected into it. Now, was it injected as a magma or injected as a really, really salty, really hot hydrothermal liquid? That's a talk for another time. I'm not going to address that. So anyway, we look at that, well, we can tell that. So we had some incorporation. So that tells us, and based on our mineralogy, if this is sanidine, that means we have a high temperature K-spar, because K-spar likes to form last in our bones reaction series before, you know, like muscovite and quartz, or just before that. But this is sanidine is a high temperature K-spar, sorry. And it forms when you have a lot of potassium and very little calcium. Okay? So, or, yeah, that's when it does. Sorry. It's hot in here. So, assuming that this is a hot temperature injection, okay, not as hot as this was, but the fact that we don't have olivines and pyroxenes tell us this was not a really hot, you know, body of melt either. So this took a long time to cool too, grow these crystals after breaking it off. After absorbing some of it, you can tell. And there's like no mica in here or anything. So this had to be moderate temperature, and just the fact that there's almost no quartz in it tells you this was saturated but not very saturated. So we can tell that too. And we know this is a siluric and that intruded this. Well, was this a body of magma or was this a surface flow? I can't tell you that. I can't, you might be like, well, it's somewhat crystalline, so it's probably a body of magma. And that very well could be. But you can't rely on that, because you look at lava flows, and if they're thick enough, they get coarser crystalline as you go into them. But there's something else I want you to notice here too that you may or may not have noticed, and it does show up on the camera pretty decently. This. What's this? Is this anything? This dark pebble looking thing? Yeah, it's a pebble. It's, sorry, I gotta read my hand. This is a pebble of this. So what's that mean? Okay, you look at this, you see this is much more coarse crystalline than this. Not much more, but enough. So when this was a magma or lava flow, some of it had already cooled, and this basically, whatever melt it was, picked it up and carried it with. So these have the same source of magma, okay? This is probably just much later plagioclase of a fracture, which makes me think that this too was a bigger fracture, not a fault, because it seems like you may have had even spaced, fractures or close to it. See, people think rocks don't do that. They do. Rocks can form brick-looking structures. I hate to be the bearer of bad news. I know in 101 they tell you that's not true, but it is. I mean, we got cleavage here. I mean, look at how straight that break is. And this one for a little bit, but down here, it's straight. I mean, obviously rocks can form, this one's not as straight. Straighter than this, though. So, yeah. Anyway, I think that's it. Yeah, I'm sorry about the jittery camera and everything. I hope you didn't get too nauseated. But anyway, that's it. If you have any questions or comments, please leave them below. And I hope that you guys learned something.